This is Math Analysis, Chapter 9, Section 8, Powers and Roots of Complex Numbers. We have arrived at maximum juice. I'm your host, Dr. D. Let's get started here. Okay, so we've talked about products of complex numbers, basically meaning that you multiply the magnitudes and add the angles. So if I were to take a complex number in polar form to a power, let's say the nth power, so I have r cosine theta to the nth power. Now if I multiply the complex numbers, meaning multiplying the radii, then I just take the radii to the nth power. And I add the angles, so what I'm going to do, rats, it's not cosine, it's cis. What the heck, you guys didn't even say anything again. Okay, so it's r to the nth power cis n theta. That's it, piece of cake. Okay, let's try an example with that. So if I have negative 2 plus 2i to the fifth. Now, you could just FOIL negative 2 plus 2i 5 times in a row. Good luck with that. Yeah, I would much rather take the polar form of this and then just plug it in this formula. So, what is negative 2 plus 2i? What is it? Oh, good. Nice. Okay. Negative 2 plus 2i is going to be this angle right here. So it's clearly 3 pi over 4. And it's, well, if we go, yeah, let's do this, just do it like this. It's 1 here, and square root 2 here. So that means this becomes negative 2 plus 2i is going to be 2 square root of 2 yeah, let's just make it like this. It's going to be okay, notice if I've got negative 1 plus I is, if I've got negative 2 plus 2i, then my magnitude is going to be 2 squared root of 2. Because basically it's going to be 2 squared plus 2 squared is 8. And there's your square root of 8. Cis 3 pi over 4. So now I've gotten this rectangular form into polar form. And so now I can apply the formula right here. I'm just going to take 2 square root of 2 to the fifth. 2 square root of 2 to the fifth. Cis 3 pi over 4 times 5, which would be 15 pi over 4. So we've got some cleanup to do here. So 2 square root of 2 to the fifth is going to be 2 to the fifth times square root of 2 to the fifth. So we'll just go square root of 2 to the fifth. Cis. Now let's clean up the angle too. If it's 15 pi over 4, we can subtract off 2 pi, which means subtracting off 8 pi over 4. So now I've got two pairs of two that band together and spring the pokey. And so I end up with a 2 squared outside, so 2 to the 7th is 128. We all remember our mental math. So I've got 128 squared root of 2 cis 7 pi over 4. So what does that mean? Well, 7 pi over 4 is down here. So I've got 1 and negative 1 and square root of 2. So basically the cosine of 7 pi over 4 is square root of 2 over 2. So I've got 128 square root of 2 times cosine, which is square root of 2 over 2, plus I sine, and sine is going to be negative square root of 2 over 2. So I should actually just make this a minus. Okay, so when I distribute this, then I've got 128 over 2, which is 64, but times square root of 2 times square root of 2, which is 2, so it's back up to 128. And same thing here, minus 128i. That's it, game over. Notice we took negative 2 plus 2i to the 5th, and we end up with 128 minus 128i. Like I said, that would have been a long process to have to FOIL that 5 times in a row. So making the rectangular into polar form, and notice the magnitude is square my negative 2, square my 2, I get 8, square root of 8 is 2 square root of 2, and then I've got the angle is going to be 3 pi over 4 because it's left and up. So there I am. So now I go 2 square root of 2 to the 5th, cis 15 pi over 4. And then it's just a matter of cleaning it up, get 128 square root of 2 cis 7 pi over 4, and then you can easily convert that back to rectangular. Okay, so let's do one more of these. Let's try one plus I squared root of 3 to the negative third. Now, if we kept this in rectangular form, it's going to be even nastier because I'm going to have to multiply this by itself 3 times and invert it and then try to fix that. But in rectangular form, it becomes a lot, in polar form, it becomes a lot easier. If I have 1 square root of 3, then that means I'm going 1 right and square root of 3 up. So the magnitude is 2. So basically this becomes 2 cis pi over 3 to the negative third. Okay, now we take our 2 to the negative third, cis negative 3 pi over 3, which is 2 to the negative third, which makes it 1/8 cis negative pi. Well, we don't have to go cosine negative pi minus I sine negative pi. Where is negative pi? It's straight to the left. So that means this is pure real, because real is right and left, imaginary is up and down. So this just becomes negative 1/8. That's it, game over. Yeah, that is it. Okay. I thought I may have screwed up there for just a second, but I was wrong. Okay, so let's try the next section here. We're going to be doing roots of complex numbers. Now this is a little bit juicier, so we're going to crank up the juice here just a bit. All right. Okay, the next formula we're going to have here is R cis theta to the nth root. So not to the nth power, but to the 1 over n power. We're going to make it to the 1 over p power because we're going to use n's differently. So R cis theta to the 1 over p power. So that's going to end up being the same type of thing. We're going to take R to the 1 over p cis. Now here's where it gets a little bit more complicated. It's not just cis 1 over p times theta, or theta over p. It's theta plus 2 pi n over p, where n equals 1, rats. You don't start counting at 1, you start counting at 0. And you keep going up until you get to 1 before p. Now you'll find out if we go all the way to p, we'll be repeating the n equals 0 case. And I'll show you that in just a second. Okay, so let's try an example problem here. If I have the equation x to the 4th equals 16, we want to find out what x is. So you probably thought that x just equaled 2. Or maybe you thought x equaled plus or minus 2. And you would be half right. But there's a lot more to it than that. X to the 4th equals, we want to put 16 in polar form. So that means it's 16 cis 0. It's 16 directly to the right. Okay, so now when we take the 1/4 power of both sides, then we have x equals 16 cis 0 to the 1/4. Okay, so this equals 16 to the 1/4 cis theta, which is 0, plus 2 pi n all over 4. So basically, if we only took one case where n was 0, then it would just be cis 0 over 4, which would be just 0. But we have 4 different n's that we're going to be using here. So let's do that now. So, let's simplify this. 16 to 1/4 clearly is 2. So we've got 2 cis 0 plus 2 pi n all over 4. Okay, so first case is where n equals 0. So if n equals 0, then x equals 0 plus 2 pi times 0 over 4. Ah, rats. Forgot the cis. 2 cis 0 plus 2 pi times 0 over 4. So this equals 2 cis 0, which equals 2, because 2 at an angle straight to the right is just 2. Okay, now, next we want where n equals 1. So we have x equals 2 cis 0 plus 2 pi times 1 over 4. So that means x equals 2 cis 0 plus 2 pi over 4. So 2 pi over 4 is pi over 2. And what is 2 cis pi over 2? Well, it's 2 straight up. That's 2i. Remember, I don't have to do the cosine pi over 2 plus I sine pi over 2 because I know it's straight up. Okay, now I do n equals 2. So x equals 2 cis 0 plus 2 pi times 2 over 4. So x equals 2 cis 4 pi over 4, which is pi. Once again, no need to go cosine pi plus I sine pi because I know pi is straight to the left. Straight to the left is all negative real. Now if I go n equals 3, then I go x equals 2 cis 0 plus 2 pi times 3 all over 4. That's obnoxious. Someday I hope to find out why it does that. But, okay, now we have 6 pi over 4, which is 3 pi over 2. So x equals 2 cis 3 pi over 2. And that's 2 straight down. Well, straight down is negative and it's imaginary. So that's it. Now, let's say we did the case where n equals 4. We want to go one more. So let's try that. So the case of n equals 4 is going to look like this. X equals 2 cis 0 plus 2 pi times 4 all over 4. So x equals 2 cis. Notice what we have is 8 pi over 4, which is 2 cis 2 pi. Well, 2 cis 2 pi is the same thing as 2 cis 0, so it's a repeat of my 0. So the n equals 4 case and the n equals 0 case are exactly the same. And if I did an n equals 5 case, it would be the same as n equals 1. So basically it's just going to repeat a pattern. Now, so here's what this says is x to the 4th equals 16, x equals any one of these 4. Notice if I take 2i to the 4th, 2i to the 4th, and clearly you can see if I did negative 2i to the 4th, it'd be the same thing. That becomes 16i to the 4th, and I to the 4th equals 1, so it equals 16. So notice it checks with both, or with all of 2, negative 2, plus 2i, minus 2i. Okay, so one more. We're going to do a cube root this time, and just like you thought the 4th root of 16 was just plus or minus 2, you also thought that the cube root of negative 8 was just negative 2. But it's negative 2 and more. Okay, so let's check this out. X cubed equals negative 8. So what we're going to do is we're going to say x cubed equals, change negative 8 into polar form. So what is that going to be? Right, 8 cis pi, because it's 8 directly to the left. Okay, so now we're going to go x equals 8 cis pi to the 1/3 power. Okay, so that equals 8 to the 1/3 cis theta, which is pi, plus 2 pi n over p, where n is going to be 0, 1, 2, and of course if it gets to 3, it's going to repeat the 0. You'll find out. So this equals 2 cis pi plus 2 pi n all over 3. Okay, so we're going to do our n equals 0 case first. And so x will equal 2 cis pi plus 2 pi times 0 over 3. So that's 2 cis pi over 3. And what is cis pi over 3? Well, let's just sketch that out real quick. So here's my pi over 3 right here. And so I have one, rats. I have 1 here, and I have the square root of 3 here, and 2 here. So cosine of pi over 3 is 1/2. So that means x equals 2 times cosine of pi over 3 is 1/2 plus sine pi over 3 is square root of 3 over 2. So I square root of 3 over 2. So that means x equals 1 plus I square root of 3. Okay, that's our first solution. Now, if n equals 1, then x equals 2 cis. Now put a 1 in here. Pi plus 2 pi is 3 pi over 3, which is 2 cis pi. Now I don't need a triangle for this because I know pi is straight to the left. So that just becomes x equals -2. And that's actually the answer we thought it was going to be, because -2 cubed is -8. Now we try our n equals 2, our n equals 2 value. So now we have x equals 2 cis. Put a 2 in, we've got pi plus 4 pi is 5 pi over 3. And so now we have to go back to our triangle. We actually are seeing this in our minds. But here's our triangle, and this is negative square root of 3, and this is 1, and that's 2. So that means x equals 2. Now, cosine is 1/2, and sine is negative square root of 3 over 2. So we end up with x equals 2 times 1/2 is 1 minus I square root of 3. There's our third cube root of -8. Now, I want you to see something interesting here. If I were to graph these 3 points on a... Oh, you know what? Before we do that, let's do one more thing. I just want to confirm for you, if we go one more, watch what happens. X equals 2 cis. Now put a 3 in. So you have pi plus 6 pi is 7 pi over 3. And that's the same thing as pi over 3, which is the same thing as the n equals 0 case. So that confirms that you are on the right track. You should, when you get to the n equals p, then you should repeat your n equals 0 case. But okay, let's graph these 3 points now on a complex plane. So I've got x equals negative 2, okay, so x equals negative 2 is right here. Now, x equals 1 plus I squared root of 3. So it's 1 plus I squared root of 3. So that would be right about here. And then 1 minus I squared root of 3 would be right about here. Now, every single time you do this, you're going to end up with a polygon where the center is the origin, and it's the same distance from the origin to each of the 3 points. It's 2, all 3 of these directions. Now, if we go back to the one that we just did before, let's graph this. Okay, so I've got the answers were 2, or negative 2, or 2i, or negative 2i. And notice, this also makes a polygon. And notice the number of sides will be the root. And this polygon is also the same distance from the origin to all 4 points. And if you check out in the book, they do example 5, they do a 5th root of 32, which is immensely fascinating because it comes out with a pentagon where the center is the origin, and all 5 points are 2 away from the origin at all 5 different angles. So basically, this is it. All you have to do is, if you have a positive or negative integer as your exponent, all you do is take in the magnitude to that power and then multiply the angle by that power. Now, if we have a fractional exponent, then instead of just going r to the 1 over p cis pi over p, or theta over p, which is what you would think to do, all you have is the 2 pi n where you're going n equals 0, 1, 2, up to 1 before the p. So that's it. Piece of cake. Have fun with these. Okay.